Hey guys, so today I'll be doing another example of trig substitution related to Atanθ theta. Yeah, so let's begin. So we have the problem, what is the indefinite integral of x divided by the square root of x squared plus 4 dx. Once again, when we have problems such as these, we want to know which formula we are going to use. So let's see, our x squared is positive, and our a squared, which is the integer of 4, is positive as well. So they're both positive. Which one will we use? Well, we can't use this because it's negative. We can't use this because a is negative. So the only values that are positive are the ones that are associated with a tan theta. So that means we will use this. So x is equal to a tan theta. So let's input our values in. So we want x inserted here, we want x squared inserted here, and we want dx inserted here. So let's get x first. X is going to be x is equal to a tan theta. A squared is 4, so that means a is 2. So we insert that x is equal to 2 tan theta. We take the derivative, and we get dx is equal to 2 secant squared theta. And we can also square it, so then we get x squared is equal to 4 tan squared theta. So now we have our x squared, and dx. We're just going to plug them into each respective value, and we're going to get this value. So it's 2 tan theta divided by the square root of 4 tan squared theta plus 4 times 2 secant squared theta d theta. All right. So now what we want to do is try to simplify it as much as possible. So what I like to start off with is the information that's in the square root. So let's first start off by taking the 4 from the 4 tan squared theta and the plus 4. Now we are left with 4 times tan squared theta plus 1. And if you know your relationships, you know that tan squared theta plus 1 is equivalent as saying secant squared theta. All right, what else do we want to do? Let's first of all start actually doing the square root. So when we take the square root, we're left with 2 secant theta. So now what do we want to do? We can cross out the 2's, and we can cross out 1 secant. So now we're left with 2 times tan theta times secant theta. What can we do now? We can move the 2 in front. So if you know your Calc 1, this should be familiar to you. What is the integral of tan theta times secant theta? You should know by heart that it is secant theta. So now we're left with 2 times secant theta plus c as our answer. But as you know, we can't use this because if we start with x, the answer needs to be an x. So how do we change this back? Remember, we made x equal to 2 tan theta. We're going to use that to convert to x. So I just divide everything by 2, and I find that x divided by 2 is equal to tan theta. So if we were to make a triangle, the opposite side would be x, and the adjacent side would be 2. As you can see, the opposite side is x, the adjacent side is 2. And now we want to find the hypotenuse. So we do the Pythagorean theorem, x squared plus 2 squared plus c squared. C is equal to the square root of x squared plus 4, and that is our hypotenuse. So you need to know from pre-calculus that secant theta is the same thing as secant theta is the opposite of cosine. So it's going to be hypotenuse divided by adjacent. So if we go back, our hypotenuse is the square root of x squared plus 4, and our adjacent is 2. So we input our information in here, and we're left with 2 times the square root of x squared plus 4 divided by 2 plus c. These two will cancel out, and it will give us the final answer of the square root of x squared plus 4 plus c as being the answer. So thank you for watching. Please like, comment, subscribe, and have a great day.